Today we'll use Pulumi, an open source, modern infrastructure as code tool to provision cloud infrastructure. Pulumi supports lots of clouds and different cloud architectures, but today we'll be creating an AWS S3 website. I've already downloaded and installed the CLI. It's available in package managers like Brew. And I've created a new empty directory. We'll run the Pulumi new command, which scaffolds a new project. Notice that there are many clouds and many languages, but we'll select AWS TypeScript. We'll select the default project name. We'll enter a description, create a new stack. A stack is an instance of our project. We can have lots of them. And we'll put this in the US West 2 region. Pulumi will then go ahead and install all of our dependencies, and we're up and running and ready to go. So let's take a look at the index.ts file, which is where our infrastructure is defined. It starts with a set of packages, and notice we're creating an S3 bucket object. That's how infrastructure is declared in Pulumi, by allocating regular objects in a programming language. We also export the bucket name at the end. Now let's run Pulumi up. This command evaluates our program and determines what resources need to be created, updated, or deleted. It shows us a preview before making those changes, and we can click details to see all of the properties on our resources. If we select yes, Pulumi will proceed with making the changes by going out to our AWS account and actually allocating the new bucket. Our update's finished. In this example, I've elected to use the free Pulumi SaaS to store my state, although additional options are available. Let's list the contents of our S3 bucket. We expect that it's empty since we haven't yet put anything in it. Now let's edit our program to upload an index.html file to our bucket. We'll create a www folder, we'll create an index.html inside of it, and let's create some simple markup. Now we need to go back to our index.ts, and we'll actually populate the bucket with this new file. Pulumi makes this really easy because we have full access to all of the programming language features. In this case, we'll use the standard Node.js FS package. We'll loop over the directory contents of the www folder. And then for each entry, we'll create a new S3 bucket object. We'll give it the name of the directory. We'll make sure it gets added to the right bucket. We will tell it to take the file contents from a relative file on disk. And from there, all we need to do is go back and run Pulumi up. This will show us the delta compared to what we had previously, which is just creating a new object. We can look at the details again, but let's proceed and actually upload this to the bucket. This will happen very quickly, just took a couple seconds. And now if we list the contents of the bucket again, we'll see the index.html file has been added. But we're not done yet. We need to update our bucket to actually serve the contents as a website. We'll go back to our program, and we'll actually add new properties to our bucket, and Pulumi will be able to detect the differences. We'll say that the index document is the index.html file that we just uploaded, and we also need to set the ACL on the objects to be public read so that they can be accessible over the internet. Finally, we'll also export the URL that AWS assigns to the bucket to make it easier to browse to the website. Now we'll go back and we'll run Pulumi up again, and this time we'll see a much more interesting output. We'll see that Pulumi detects that there are two diffs. The website has been added to the bucket and the ACL has been changed on the object. Indeed, by clicking details, we see the actual value changes. Let's click yes to actually perform the deployment. It'll happen very quickly, and we'll see that the URL is printed. All of our changes are now live, so we can curl the resulting S3 URL and see the contents of our index.html file. Great. Everything seems to be up and running. Now, finally, there's one last step. We're going to destroy all of the resources we just created so that nothing's left behind. We run the Pulumi destroy command. It looks a lot like up, but in this case, it's actually just deleting everything that's been created. Finally, we can remove the stack itself, which deletes all history and all traces that had ever existed. Although this example used TypeScript, AWS, and deployed manually from the command line, Pulumi supports many different languages, many cloud environments, and CI/CD integrations to make automated delivery easier. I hope you've enjoyed seeing how easy it is to create, deploy, and manage modern cloud infrastructure using Pulumi. Pulumi is open source and free to use. Give it a try today.